This method can help answer key questions in the behavioral neuroscience field, such as how to better understand underlying biological mechanisms of PTSD. The main advantage of this technique is it is robust, reliable, quantitative, and can be performed in multiple species.
Begin by setting up one set of fear conditioning chambers to serve as context A, and a second set of fear conditioning chambers to serve as context B. Place each fear conditioning chamber inside a sound attenuating cubicle to prevent intrusion of outside noise. Then place grid floors in each fear conditioning chamber for foot shock delivery, using a different grid pattern for each context to differentiate floor texture between contexts. Next, place black plexiglass triangular inserts in context B to differentiate the internal layout of the two contexts. Wipe down the chamber walls and doors and spray the pans beneath the grid floors with a diluted cleaning solution. After the grid floor is cleaned, connect a shock generator and scrambler capable of delivering a 1 mA or lower amplitude shock to each grid floor for foot shock delivery. Finally, use a multimeter to test the current being delivered by the shock generator by placing each probe on a different bar of the grid floor, and confirming that the desired shock amplitude is produced. On day 1, set up context A with grid floors and visible light. Ensure the multimeter is attached to different bars to confirm the desired shock amplitude. Transport animals from the vivarium to the experimental room in their home cages placed on a cart, and place individually into the 4 fear conditioning chambers. For mouse experiments, use the shock generator and scramblers to deliver 10 1-second 1 mA foot shocks, randomly presented over 60 minutes through the grid floors of the chambers containing trauma-conditioned subjects. For rat experiments, use the shock generator and scramblers to deliver 15 1-second 1 mA foot shocks, randomly presented over 90 minutes through the grid bars of the chambers containing trauma-conditioned subjects. After 90 minutes for the rat or 60 minutes for the mouse experiments, return all animals to their home cages, and promptly return to the vivarium. On day 2, set up context A and transport animals to the experimental room as done on day 1. Place animals in context A for 8 minutes without shock delivery and video record the behavior during the entire session. After 8 minutes, return all animals to their home cages and promptly return to the vivarium. On day 3, set up context B with a different set of grid floors from the ones used in context A and black triangular or white curved plexiglass inserts. Use infrared or near-infrared light if necessary to illuminate the chambers, and check the shock amplitude with the multimeter. Wipe down the chambers and spray the pans beneath the grid floors with the solution not used in context A. Next, transport animals from the vivarium to the experimental room in a black plastic tub, and place them individually into fear conditioning chambers. After a 180-second baseline period, deliver either a single 1-second 1 mA foot shock for rats or a single 2-second 1 mA foot shock for mice to all animals. Then remove all animals 30 seconds after shock delivery and promptly return to the vivarium. On day 4 of the procedure, set up context B as done on day 3. Transport animals from the vivarium to the experimental room in the same transport as done on day 3. Place animals in context B for 8 minutes without shock delivery and video record freezing throughout the session. Finally, remove all animals after 8 minutes and promptly return to the vivarium. Results indicate that animals in the trauma condition showed significantly higher levels of freezing in context A compared to the no trauma controls, indicating acquisition of fear to the trauma context. Both the trauma and no trauma animals showed minimal freezing levels that did not differ from each other. Further, the trauma animals showed lower shock reactivity compared to the no-trauma controls. And trauma animals showed greater freezing compared to the no-trauma controls, indicating that exposure to the traumatic stressor increased fear immediately following the mild stressor.
Following this procedure, other methods like the elevated plus maze, open field, and light dark box can be performed in order to answer additional questions like how trauma affects anxiety-like phenotypes.